Hello students, in first lecture on sets relation functions, I have talked about the definition of sets, then we have discussed the number systems, etc. In our this second lecture, we are going to talk about subset concept, types of sets, equality, and if possible then we will also talk about the operations on sets. Okay, so the types of sets. Now if I take, say, A is equal to set of those set of real numbers x belongs to R such that x square plus 1 is equal to 0. Then we know that square of any real number is a non-negative number. It is always greater or equal 0. That non-negative number plus 1 is also greater or equal 0. So for any real number x square plus 1 is never 0. So there is no any real number, okay, contain no element. No real number satisfy equation x square plus 1 equal to 0. So what is definition of empty set? This is empty. Set containing no element is called as empty set. Okay. So first one, empty set. Set containing no element. Is empty set or null set. Null set. And it is denoted by phi or just this symbol. Okay. Now if I ask, find natural number which is neither prime nor composite. So what is say B set? Okay. B set now. Set of n belongs to n such that n is neither prime nor composite. Now what is definition of prime number? A natural number p other than 1 is said to be prime natural number if it is only divisible by 1 and itself. It has no factor other than 1 and itself, and it must be not 1. So 1 is not prime. Then what is definition of composite number? A natural number n other than 1 is said to be composite number if it has factor other than 1 and itself. For example, if I take 2, 4 or 8. If I take 8 natural number, it is divisible by 1, then it is divisible by 2, it is divisible by 4, it is divisible by itself 8. So it has factors 2 and 4 other than 1 and itself. So that 8 is composite number. So number having factor other than 1 and itself is known as composite natural number. So what is the number, or which is number which is neither prime nor composite? It is just singleton 1. It contains just single element. So what will be definition of singleton set? A set containing just one element is called as singleton set. Okay, a set containing only one element is called as singleton set. Set of Prime Minister of India or set of capital of India, but a set of capital of Maharashtra, that is unique. So those sets are singleton sets. Those sets are singleton sets. Okay. Then, as I am talking about set containing no element means it contains zero number of elements. Set containing one element. If I take the set of solutions of quadratic equations, ax square plus bx plus c equal to 0, then your idea that quadratic equation has no roots or it has repeated one root or it has two roots. So solution set contain at most two elements. So number of elements in that set is finite in that solution set. So what will be finite set? Set containing finite number of elements is known as finite set. Okay, finite set. A set containing finite number of elements is called as finite set. Okay. If set A contain say k elements, then we write, or it is denoted by number of elements in A or cardinality of A is equal to, or sometimes in some books it is also denoted by this symbol is equal to k. So these are notations for number of elements in that set. Okay, finite set. Then as I come across finite sets, so there must be concept of infinite set. Set containing a set which is not finite. It's called as infinite set. For example, if I take our set of natural number, whole numbers, set of integers, okay, set of real numbers, set of rational numbers, set of complex numbers, then set of prime numbers, set of all prime natural numbers, prime integers, set of even numbers, okay, even numbers, etc. are infinite set. Again, you can observe instead of natural number or whole number or z, in natural number what we can do, after 1 you can count 2, after 2 you can count 3. So 1 after 1 it is possible to count the numbers, elements in natural number set or whole number set 0, 1, 2, 3, dot dot etc. Or in z, I can take 0 first, then positive integer 1, then negative minus 1, then 2, minus 2. Okay. So what natural number 1, 2, 3 and so on. For W, first entry is 0, 1, 2, 3 and so on. Okay. Then Z, I will take 0 first, then 1, minus 1, 2, minus 2 and so on. Okay. Are countable sets. are countable infinite sets. So one after one, these sets are countable. But now, if I take a real number set, then after 0, you can take 0.1, but in 0.1 again 0.01 is there, in 0.01, 0.001 is there. So between two real numbers there is other real number, and that process never stops. That process never stops, and due to that it is impossible to count the real number set. And hence superset of real number, which is complex number, it is also uncountable set. Okay, so what is the other type of infinite set? Okay, set of real numbers, then set of complex number. Okay, if I take a set of irrational numbers, okay, if I take set of all real numbers in A and B for A less than B are uncountable infinite sets. Uncountable infinite sets. Okay. Q is also countable set. Set of rational number is countable. How it is countable? What is a rational number set? Contains the number of elements of type P by Q where P and Q are integers and denominator Q not equal to 0. Or I can take denominator to be just natural number set. So by taking firstly denominator to be 1, and writing numerators to be all integers. Okay. 0 by 1, 1 by 1, minus 1 by 1, 2 by 1, minus 2 by 2. In this way, I will cover all integers firstly. Then with denominator 2, these numbers 0 by 2, 1 by 2, minus 1 by 2, 2 by 2, minus 2 by 2. Then with denominator 3, it is possible to count elements in set of rational number without repetitions. If it is repeated, ignore that number. So counting process is possible in set of rational number. So infinite sets are classified into two classes: countable infinite set, uncountable infinite set. So these are the types of sets. Empty set is also countable. Empty set is also finite. So according to I am considering countable set to be infinite set. In some book, countable set is a set which is finite or infinite countable. Okay, but according to me, I am just taking countable set is always infinite set, and which is equivalent to set of natural number. I am not interested what is meant by equivalent sets, etc. here. Okay. So as here I have written set of all real numbers in A and B for A less than B. Then how to write that set now? That is the problem. So for that we have to study intervals. Okay. Intervals. So for AB belongs to R with A less than B. Okay. First, AB is equal to set of X belongs to R such that A less than X less than B. Set of those real numbers which are greater than A and which are less than B. This is known as open interval. open interval AB. Okay. Second, close interval. Close interval. So firstly I will take open interval. Second, for A less equal B in R, close interval AB is equal to set of x belongs to R such that A less equal x less equal B. This is close interval. Close interval AB. If A equal to B, okay, open interval AB for A less than B, open interval AB is uncountable. Is uncountable set. Okay. For A equal to B, close interval AA is singleton set is finite. And for A less than B, close interval AB is uncountable. Is uncountable. Third, for A less than B now, open close, close open intervals are defined. Then range. Range. So for A belongs to R, A infinity minus infinity to A are open range. Infinity minus infinity are not real numbers. They are not included in that set. Okay. And close open interval A infinity minus infinity to A, these are close ranges. Close range. Okay. Five. R is equal to R is, or what is minus infinity to infinity? It is set of x belongs to R such that minus infinity less than x less than infinity. This is precisely set of real numbers. So I can denote set of real number by this other symbol minus infinity to infinity. This is the other notation for set of real numbers. Okay. So infinity minus infinity are not real numbers, that are just notations. Real number approaching towards infinity on right side, real number approaching towards minus infinity on left side. Okay. So these sets, intervals, we cannot write these intervals in listing method or roster method. It is only possible to express these intervals in set builder form method. Set builder form method. So set builder form method is very important method. Now we have to see concept of subset. Let A and B be two sets. A be two sets. If every element of A is element of B, then we say that A is subset of B. Okay. Then A is a subset of B. A is subset of B if each element of A is an element of B. That is, x belongs to B. That is, if x belongs to B for for all x belongs to A symbolically. Okay. If A is subset of B, then we write A is subset of B, then we write A is subset of B, or B contains A. B contains A, which is also read as B contains A, or B is superset of A. Superset of A. Okay. So this is the other term for superset, subset. Example, by definition of natural numbers, etc. Natural number empty set is subset of natural number set is subset of whole number is subset of Z, okay, is subset of Q, is subset of set of real numbers, is subset of set of rational number, complex number, etc. Okay. Set of all vowels is subset of set of all English alphabets. Is it clear? Then, if proper subset, etc. Okay. Proper subset. If A is subset of B and there exists B belongs to B such that B doesn't belong to A, then A is proper subset of B. Subset of B, which is denoted by, which is written as A subset of B, proper subset of B, or A just subset of B. So I can write these are proper subsets. Clear? As there is concept of proper, means if A is subset of B and B contains some additional elements, then that A is called as proper subset. So it may happen that for given set A, every element is element of A again. So by definition of subset, A is always subset of A. A is always subset of A. Okay. So note, first, phi and A are subsets of A. Subsets of A. These are called as trivial subsets of A. Subsets of A. Any set has at least two subsets, empty set and itself. Empty set and itself. Okay. Second note, trivial subset. Then there is concept of proper subset. Improper subset. Improper. A is, okay, A is improper subset of A, and any other subset of A is proper subset of A. Empty set is also proper subset of A. Okay. A is improper and any other is proper subset of A. This is concept of subset. Now, we can also denote we can represent this diagrammatically. If I write elements of set in some circular region or elliptical region on xy plane, then representation of that set by diagram is known as the Venn diagram. Mathematician Venn firstly represents sets with help of diagrams. So I can represent set by Venn diagram also. And that Venn diagrams are very useful while proving the relation between sets. Relation between sets related to the operations defined on sets. So Venn diagrams are also important. So next concept is important for us, universal set. Okay, so as I am a mathematics teacher teaching at graduate level, I am teaching to first year, second year and third year students. So my aim is to keep the record of first, second and third year students. So for me, what is the universal set in my college? It is nothing but set of all students studying mathematics for first, second and third year. But for principal of college, what is the universal set? Set of all teachers, set of non-teaching staff, set of students studying in colleges. If I have to talk about prime numbers, even numbers, odd numbers, prime number concept depends on divisibility. Prime number concept depends on divisibility. If I have two numbers A and B, then A is said to be divisible by non-zero number B if A is a multiple of B. 2 divides 8 because 8 is equal to 2 into 4. 2 into 4. So you are talking about divisibility in natural number set. Divide one natural number by other, find quotient, remainder, and then express dividend as quotient into divisor plus remainder form up to 6-7 standard. But when you come across the real number, then you haven't studied the concept of divisibility. Divide one real number by other and find remainder, quotient, etc. That type of examples you have not studied. Because what is happening set of real number or rational number in R, Q, R, C, A divided by B for AB belongs to, if I have this, for AB belongs to X, B not equal to 0, A divided by B is same as A into 1 by B. So I can express division with help of multiplication, and that's why division has no meaning there. So division operation is expressed in terms of multiplication, and so it is not necessary to talk about the prime number concept in those sets, rational number, real numbers or complex number. So prime number concept is only up to set of integers. Even number is a number which is divisible by 2. Odd number is number which is not divisible by 2, and divisibility concept is only up to set of integer. So prime number, prime, odd, natural number, prime, even number, odd number, these concepts are only related for set of integers. So while studying those concepts, universal set is nothing but set of integers. Okay, so what is the universal set? A set containing all subsets which are taken for study is known as universal set. Okay, set containing all subsets taken for some study or purpose is known as universal set. Example, universal set for set of prime numbers, even numbers, odd numbers, or study of GCD, greatest common divisor, or LCM of numbers is set of integer. Is set of integers. Zero. Even though set of rational numbers, set of real numbers, set of complex numbers are superset of integers, that sets can't be taken as universal set. Remember it. Because I cannot talk about the prime number concept instead of real number. There is no any prime number, there is no even number, there is no odd number concept for a real number, complex number, or rational number set. Okay, so while talking about the sets, I am also clearing so many basic concepts in mathematics, and that's why set topic is very important. So with this discussion, we'll stop our 2 days lecture. We'll meet in next session, and we'll study operations on set and properties of operations on sets. Thank you. Bye-bye.